Okay, so question number 10. Predict the charge of the ion formed by each element and write the electron configuration of the ion. So first, let's write down all the different electron configurations of our ground state elements. So for A, we have selenium. And just to make it easier, I'll do them in the shorthand configuration. Okay, so when writing the electron configuration of certain elements, we first need to divide our periodic table into the different orbital sections. So these first two columns in the light blue is the s orbital, and this section in the green is the p orbital. The middle D is the d orbital, and these are all the transition metals. And the last two rows, the lactanides and actinides, are the f orbitals. So when we write the electron configuration, starting from hydrogen, you move left to right across the periodic table until you get to your desired element. Typically, you want to write from lowest to highest energy state. So when we write out the electron configuration, we would first write the row number and then the block letter. So let's do the long way of writing the electron configuration just so that we can see an example of how to do that. So starting from hydrogen, we write the row number and then the block letter, which is S. And then in the superscript, this tells us how many electrons are in that orbital. So there are 2 electrons that can fit in an s orbital. And then if we go to the next row, it's going to be 2s and then 2. And then moving across to 2p, it's going to be 2p6. Then moving down to the next row is 3s2 and then 3p6. And when we get to the next row, some people write 4s2 before the 3d, but most of the times, since the 3d orbital is in lower energy than the 4s, we're just going to write that first. So I'm just going to write 3d10. Oh, let me bring it down a bit. 3d10, and then 4s2. And now up to the selenium, we just write 4p and then count out all the electrons until we get to our desired element. So we count 1, 2, 3, 4. Okay, so this is the electron configuration of a ground state selenium ion. And we can write the shorthand configuration as well. So if we look at the noble gas that comes before selenium, it's argon. So we put argon in square brackets, and then we just continue on writing the electron configuration just like normal. So it's argon, and then 3d10, 4s2, and then 4p4. Okay, so this is the electron configuration of a ground state selenium ion, but we also want to predict the charge of the ion formed by each element. So naturally, we just assume all of these elements want a full octet. So assume electrons follow the octet rule. So let's look at our selenium again. So if selenium wants a full octet, it's much easier if it were to gain an extra 2 electrons. So when we have a selenium 2- ion, that means it gained 2 electrons, making its new electron configuration the same as krypton. Okay, so now let's go to the next element. Do it in a different color. So next we have barium. I'm just going to write the shorthand electron configuration for barium. So it is found right here, atomic number 56. So its electron configuration would be xenon and then 6s2. So for barium to have a full octet, the easiest thing for it to do is to remove its last 2 electrons. So when we remove electrons, we have a plus charge. So in this case, barium 2+ will most likely occur, and it's just going to have the same electron configuration as xenon. Okay, so on to the next element, strontium. So let's find strontium on the periodic table. So it's found right here, atomic number 38. So its electron configuration is krypton and then 5s2. So this is pretty similar to the barium. It would just rather lose those 2 electrons to become strontium 2+, and its new electron configuration is the same as krypton. Now let's do our last element, which is cesium. So the ground state electron configuration for cesium is found here. So its atomic number is 55. And its electron configuration is xenon 6s1. So again, it's easier for the cesium to just remove its last electron to become cesium+, and it's just going to have the same electron configuration as xenon. So now let's see what the junior tutor said. The electrons given follows the octet rule. So selenium has 6 valence electrons, so its possible ionic form is selenium 2-. So they said that it will have the same electron configuration with krypton, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So for barium, its possible ionic form is barium 2+, and they wrote out the whole thing. It'll be the same electron configuration with xenon. Strontium has 2 valence electrons. Its possible ionic form is strontium 2+. So it'll have the same electron configuration as krypton. Yep. And then cesium has 1 valence electron. So its possible ionic form is cesium+. So this will have the same electron configuration as xenon. Okay, so this shows that cesium plus and barium 2 plus are isoelectronic, meaning they have the same electronic configuration. So that means they're also isoelectronic with xenon as well. So this solution is correct.